from Microbe TV, this is TWiP, This Week in Parasitism, episode 179, recorded on January 8th, 2020. Happy New Year, everybody. Vincent Racaniello, and joining me today here in New York City, Dickson Despommier.
Hello there, Vincent.
And Daniel Griffin.
Hello, everyone.
Hello there, Daniel.
In vivo veritas in 2020. Happy New Year to both of you.
Thank you.
Thank you. Thank you.
I hope you have a wonderful 2020.
So do we.
It's the kind of numbers that you don't see very often.
You do not.
Actually, yeah, the 2020, yeah.
Because 1010 was a long time ago,
Yeah.
and that was a bad time.
1919 was... Yeah.
It was like when England invaded France or vice versa, right?
Exactly.
What was the name of that war?
War of the Roses?
No, not Roses. It was
100 Years War.
Anyway. And then 3030, none of us will be here.
No.
And maybe the
And
Earth
2121 we won't be around for.
21, 22, 22, yeah. But yeah, 21 is too far.
22 will be cool. I would like to be around for that, just for the cool.
There's no
effect.
palindromic upcoming numbers that we could be here for?
No, 2020. 1919.
That's not a palindrome.
We already did 1919. What?
I said palindromic.
Like where it goes backwards, forwards.
He knows what
the
a
same.
I don't care
He's
about
a good
those.
molecular
I
biologist.
like
You like
the 2020s.
unusual numbers.
This is a great year. This is going to be a great year.
Okay.
All right, so we last recorded in December. Is that true? Maybe,
Well,
Early December, about a month ago.
was it December? I trust you.
I feel like I want to say December
Yeah, it was
6th.
December 3rd.
3rd. Okay, yeah.
And that Friday I went to Singapore, and you went to Morocco.
I did.
Did you go anywhere, Daniel?
I was a little island off the coast of Venezuela. Just got back.
What island is that?
Curacao. It's in the Dutch
Curacao,
Antilles.
yes.
Curacao, we've heard.
a
Am I
big-
pronouncing it correctly? I keep getting
You are.
corrected.
There's a
You
liqueur
mentioned
named
that.
after
Now I
that one.
remember. Now I remember you mentioned it before. You went to work?
No. This was a
Vacation.
family vacation.
You took the whole
Did you
family.
scuba?
So my wife, my 3 kids, my wife's sister, her sister's boyfriend,
Wow.
they went scuba diving.
That's part of the Dutch Antilles.
It is. And the to leave for the scuba diving, you had to be at the boat by 8 a.m. And my 2 daughters were like, 8 a.m.,
No,
that's
that'd be
not going to
joking.
happen. So I was like, all right, I guess I'm not going.
Right.
I do scuba dive, but I
Yeah,
did not
yeah.
get a chance to this time.
It has some of the best scuba diving, though, in the Caribbean. There are 3 islands, and one of them begins with B.
Bonaire.
Bonaire. It supposedly has the most
The
intact
ABCs,
coral
right?
reefs.
Yeah.
Aruba, Bonaire, Curacao.
That's right. And Curacao you can drink it as well as just stay on the island.
So
But we windsurfed. We did a lot of
That's
snorkeling,
nice.
swimming. It was great. Beautiful. And
And
it was nice to get
you didn't
time
see
with
any
it.
patients.
Awesome.
No,
Good.
I didn't.
Wonderful.
Little break. Did you spend a week there or more?
It was a week. Yeah.
Right.
Very good.
And we were in Morocco. I would highly recommend it for anyone who has never been. You should do it. It's a wonderful country.
I've never been.
It's got lots of interesting sights to see,
The
including
food is good, right?
the Atlas. The food is wonderful. It's all tagine based.
What's
And
that?
there's a tagine is a cooking vessel. It's made out of ceramics.
Mhm.
And it sits on the stove. And it's a circular dish, which is about 2.5 inches deep, with a turban style, like a pyramid
Yeah.
with a little handle on the top so you can check out to see what's happening. And they have something there that you would really enjoy. It's a sweet mint tea.
Mm.
And they pour it with a ceremony. And they start it out at the cup, and they stand up, and they're actually with the teapot above their head, and there's a stream of tea that goes right down into the glass. They don't miss.
Mm.
It's quite remarkable.
Now, is this where you would find like couscous?
Couscous is a definite
Moroccan?
staple. Definite.
And what about tahini?
No, that's more Middle Eastern. They've
Middle
got
Eastern.
chicken, beef.
Tabbouleh is also Middle.
Tabbouleh is mostly Middle Eastern.
All right.
Yeah, this is mostly African and Spanish because of the influence, and French.
So it's in Africa, right?
It is in North Africa. It's the country opposite Gibraltar.
And do they have mosquitoes?
You betcha.
Do they have mosquito-borne diseases?
Of course they do, but we were there in December, so that was rather cold. In fact,
Really?
one of our day trips, we went over the Atlas Mountains to go to this little town. No, we went to the Sahara Desert, excuse me. And the next morning when we woke up, there had been so much snow that road was closed. We had to go back another way, and it took us 11 hours to get back to Fez.
Do they have malaria in Morocco?
I don't ask the expert.
You know, Daniel?
No, I don't believe they do.
They have some other things. I'm sure of this. They have leishmaniasis. I'm positive they've got leishmaniasis because it's all around the Mediterranean basin. It's possible that they have some malaria.
I'll take a look.
I think they have the potential for some of the viral diseases that we're mostly concerned about from Africa. You'd think of West Nile, for instance, and maybe not Zika, but I think some other.
They don't have Ebola up there.
No, they don't. That's too far north.
It's interesting with Africa, right? We make this distinction between sub-Saharan Africa and Africa above. What we call it, supra-Saharan.
This country,
North Africa.
half of this country is in the Sahara Desert. So this has got the Sahara Desert
really?
as
Half
part of its geography.
The southern half?
Yeah, and I was actually at the desert interface between the city, the last city, and the desert, and I got to pick the dust up in my hand. The dust, it's more
fine.
dust. It's
very fine
extremely fine, which is why it can blow all the way across the Atlantic Ocean when they have lots of windstorms.
Scirocco, right?
Correct.
Takes a ride in the Scirocco.
That's right. And in fact, we learned from a TV series which was on a little while ago that the nutrients locked up in the grains of sand from the Sahara fall as manna from heaven onto the Brazilian rainforest and feeds the rainforest with. And we don't think about deserts as being places of habitation, but there are tons of animals and people live there too. And all of their waste products tend to build up in the sand, and all that blows across as well. So you can see where it's not just about sand; it's about all the organic material that gets locked up in it as well.
Interesting. A very interesting ecology.
Very interesting. Yeah, we had a great time.
Good.
Really wonderful time.
Well, speaking of Africa,
yes.
I think our last case
go back
place
to our,
there, right?
go back to our case. All right. So we'll bring everyone back to Uganda, to sub-Saharan East Africa. All of our listeners who are tuning in for the first time are tuning back in, and we'll both be reminding you and telling you the story for the first time. Here we were, eastern border of Uganda, right by Kenya. We're up in the mountains. And these two young boys come into the clinic without their parents. And I think I mentioned initially I joked with the one boy that he was much too young to have a son. But he was actually 15 years old, but looked younger than stated age. And he's there bringing in his 1-year-old brother.
Right.
And the story is, the reason he's bringing his brother is that he describes that his 1-year-old brother has been passing worms. He initially describes them as long, white, and flat, but then we go through Parasitic Disease 7th edition. We have a couple copies there in the clinic,
right?
And
he actually points out that he recognizes what he has been seeing in the stool, and it actually corresponds to a pinkish worm. We'll say 7 or 8 inches long. It's actually round, so not flat as he initially described. So he points to this, says he's seen those in his brother's stool. We look at the younger brother, and the younger brother is 1 year old, but seems small for stated age. He has a protuberant abdomen, so his abdomen is sticking out quite a bit.
Right.
And we asked a little bit about diets, and we found that what they tend to eat, mostly a high carbohydrate diet, so a lot of deep fried yams and other types of root vegetables, I'll say. Some cabbage, some rice, soybeans, pumpkin leaves, banana, things like that. And one of the points we made is, so how do we know that this little brother has these in the stool, is very young children usually won't use the outhouses. And it's a fear on both the parents and the child part that someone might fall through.
Sure.
And, where I stayed, they had sort of a built up area over the hole. But a lot of these, it's really a big hole is dug in the ground, and there's a bunch of branches and such that are put over it. So there's a hole. So you're actually going out on this wooden,
you're going to balance,
and you're balancing on this. You're hoping it, you know, it handles your weight. As I look over at Dickson here, you're hoping it.
Thanks a lot.
It doesn't, like, you know, because I'm a little larger, right, than a lot of people in Uganda. So when I go there, I'm a little worried. Like, is it gonna withstand my weight? Because if it doesn't, I'm going to be one miserable chap.
Exactly.
So the older brother, though, his stool is just going off into the abyss. So we don't know if he has this as well, but we brought that up as a concern. Does he have this problem as well, but doesn't know because his stools are going off into the abyss while the younger brother is just defecating around and you're actually able to see the feces.
Right.
All right, we have a bunch of guesses, as usual.
Indeed.
First is from Sophia. Dear Twipsters, I think you will be reading this in 2020. So Happy New Year and all the best. Thank you for another year of TWiP episodes, and thank you for taking the time to further explain things for me. I really appreciate this. Let me venture a guess. I looked for the picture the boy was shown in the 6th edition, but after a while I gave up, as most of the worms look the same to me. Did I miss a picture showing worms in stools? Anyhow, I would say that the baby is suffering from ascariasis, among other things. The protuberant belly could be partly due to the worms and partly due to kwashiorkor, given a diet based on carbohydrates. In addition, given the dysentery outbreaks, I wonder if and how these boys restore their gut microbiome to a healthy level. Given the older boys' stunting, I want to say kwashiorkor might be the main cause for it, since it inhibits growth in the first years of life to a point that a child can never catch up with expected height, even if given proper diet after year 3. What to do? 1, treat the patients. 2, educate children and adults on hygienic practices. 3, explore ways to introduce protein in their diet. 4, explore possibilities for clean water in the area or cholera, etc. We'll come back. It seems so hard. I saw the pics on the Facebook page. Good job. Nice page. Please keep us posted. I'm assuming the kids above were not affected by HIV as well. Vincent didn't ask this question last time. Safe trips this year and all the best. Greetings from Greece. Current temperature 8 degrees Celsius. Yes, we do get winter and snow and sub-zero temperatures in Greece. We just got lucky this year with warm temperatures due to anticyclones from the Sahara. I won't complain about that.
Right.
Dickson.
So she brings up a couple interesting things.
Very.
You know, so one of the, I don't know if our listeners are familiar with kwashiorkor versus marasmus and kind of the distinction there in terms of malnutrition.
Right.
And unfortunately, in a lot of areas like Uganda, there really is an issue with people either not getting enough calories or not getting enough protein. So your marasmus, right, would be just a general caloric insufficiency, while the kwashiorkor is more specific, going to be a protein malnourishment. And without the protein in the intravascular space, you get a lot of swelling. You can get protuberant bellies. And I worry about the area I go to in Uganda because with the global climate change, you know, they're already living on the edge in a lot of ways as far as getting enough food and very challenged as far as getting enough protein in the diet. So, no, I thought those were excellent points to bring up.
Because the climate's making it hard to grow. What's the climate impacting this? How is it?
So the rains are really critical, and the rains have to come at the right time of the year, and they have to come with the right amount. So I think I mentioned when I was there, they had the worst rains they'd ever had.
Exactly.
And about a year ago, just a couple weeks before I arrived, they had severe rains as well, and really a massive landslide to the point where there were boulders the size of homes, and a village just above us was completely taken out. And it actually came right by, I'll say, about 10 to 15 feet from the back of the one of the health centers that I went and visited. And just this whole landslide came down. So too much rain and the instability, because, you know, you're growing crops up on these hillsides or the lack of rain, and then your crops don't grow.
That's right. And
the cabbages, the rice, the banana plants, all the other critical plants, if they don't grow, then
Right.
All right.
Alita writes, greetings. If you ask me, spelled A-S-C, this sounds like Ascaris, a lumbering fan. Let me read the next one, too.
Hey, lumbering fan, you get it?
I do.
That was all very clever.
Very good.
George writes, Dear doctors, I have been listening to your podcast for a while now and finally decided to write my guess on the case. I'm a PGY3 in internal medicine and just matched to infectious disease fellowship. I am very thrilled about my future career path. I believe that the boy may have Ascaris lumbricoides infection since the description of the worm is round, pink, and 8 inches long. Also, the patient's appearance suggests this infection too: protuberance, round abdomen, and delay in physical development. All could be from malnutrition due to the heavy worm burden. Treatment would be a single dose of albendazole or mebendazole. I want to thank you for what you do. Keep up the great work. Sincerely, George. Thank you, George.
Postgraduate year 3, right?
That's right.
Yeah, I'd love
That's
to hear
right.
where he's headed. So he's just finished his internal medicine training, and now he gets to do the
cool.
good stuff.
Very cool.
Courtney writes. No, this is Daniel. Sorry.
Oh, is it mine? I'll
Yours.
jump in. That
Sorry.
works. Courtney writes, Dear doctors, I thought this case would be relatively straightforward, but after spending quite some time on it, I now know better. I originally started my journey in PD7 in Appendix C's photos. Unfortunately, I didn't find any photos of an 8-inch or about 20 centimeter pinkish worm. So looking at the diagnostics and laboratory abnormalities table for distended stomach, I started my search amongst the hepatomegaly worms. I narrowed it down between ascariasis and schistosomiasis. Both match the location. Both cause a distended stomach. Both can be spread via the contaminated water, and both can cause a short stature. However, schistosomiasis worms are about 15 millimeters, a long far cry from an 8-inch worm about 200 millimeters. Ascariasis seemed like the best match, but PD7 doesn't mention anything about worms being passed in the stool, and I couldn't find a length for it. I then went on, I see Dickson rolling his eyes, but I then went on an internet jaunt, scrolling through PD7 and saw a few other things, but none of them quite matched. Most were too small or needed to be transmitted via animals, undercooked meat. I revisited ascariasis, and though it was lacking a few things, I decided it's the best choice. My official guess is ascariasis.
Right.
Diagnostics would be looking at the egg, stool samples for eggs. Treatment is usually albendazole or mebendazole. Unfortunately, if the infection is severe enough, surgery may be required to remove the worms. I am curious what happens after treatment. Isn't there a strong chance that the child, and it sounds like his brother, could become reinfected with worms? Also, is there ever any intraspecific, interspecific competition that happens? Or the worms, and this just isn't for ascariasis, but all internal parasites, derived from a singular infection? Or are there hundreds of worms that come from being repeatedly infected as they continue to drink the contaminated water? Does having all these worms impact if you can get other parasites like hookworm? One last question, Dr. Griffin. What are the logistics like for your travel? Do you pick where you go, or are you assigned? Does each clinic have different specialists? Or are you all general practitioners who know a little bit of everything? Are there doctors continuously at this clinic, or do the doctors come for, say, 10 days, every few months? Are the clinics able to have different things like MRIs, CAT scans, etc.? And what happens if someone needs major surgery?
Right.
Stay curious, Courtney.
Stay curious.
Exactly
All
right.
Like-
Should we hit a few of those while we're here?
Go ahead.
What do you think about this? Like lots of worms? Can you get lots of ascariasis
Well,
worms?
I would say, first of all, that if they were passing worms, that certainly couldn't be schistosomiasis because those worms don't get passed.
It says it right in the book.
No, we have a lot. If they were to read the chapter on ascariasis.
Yeah, it's all in the chapter.
It's all in the
To
chapter.
read it.
There's no pictures in the appendix that shows, although some worms can lodge in the appendix, it's not that appendix what they're referring to. So schistosoma worms are very small and would not probably be noticed by anybody, even if you ran across them, in a culture dish or something else that you could see them in the lab. But ascaris certainly is impossible to mistake for anything else, I think. So, that was not a guess at this point. It had to be that or nothing.
Yeah, I think the competition is interesting, right? Because some worms, we've talked about with tapeworms, there may be some sort of a territorial aspect, right?
Yeah.
You end up
that's
not
true.
getting hundreds of tapeworms.
Right.
I think you described a case once of someone who had 4 or 5, which is usually people only have one, interesting enough,
That's
right?
right. These are the Taenia type tapeworms, but there are others, the Hymenolopus tapeworms. Definitely you can have more than one, and some children develop many different numbers of those Hymenolopus diminuta and H. nana. Either one of those can cause multiple infections. But the Diphyllobothrium latum, the fish tapeworm, usually just one Taenia adult. Mm-hmm. And it's a crowding effect. I think that is a crowding effect at that point. But, strangely enough, dogs can acquire millions of Echinococcus granulosus adults. Those are, it looks like the villi of the intestine when you dissect an experimentally infected dog and look at the intestine. And you think you're looking at the intestinal tissue, but actually you're looking at the tapeworms.
Wow.
Yeah.
The picture of the big jar you have.
Yes, those are ascaris.
Ascaris, right?
Exactly.
Yeah. Or the little girl in the book. You've got the girl with the distended belly.
And then we've got the
and then just
worms.
a pan full of worms.
Exactly.
A pan full of worms, exactly.
And the comment about requiring surgery occasionally, sometimes there are so many worms that it induces a cessation of peristalsis. When that happens, C. difficile takes over because the anaerobic environment is conducive to the spores germinating. And then you can start to get really serious problems of erosion of the small intestinal wall. At that point, if you don't do a surgery, the patient could die from a peritonitis.
Did you tell a story of someone who came and you gave them a drug and waited for the worms to come out?
Yeah, that was for a tapeworm. That's right. And she had actually 7 smaller versions of Taenia tapeworm. She didn't have an adult tapeworm. She did have the adults, but they were stunted in their growth. So it indicates that they were competing with each other for the resources.
Got it. Daniel, do you want to answer something?
About the travel. So I always pick where I go. I never get assigned, which is nice for me. And actually this last fall, I originally was going to be heading to Ghana. We've had talk about Ghana in the past. And some logistics fell through on that, so I ended up back in Uganda. I was like, well, I'm heading to sub-Saharan Africa. I'll just head to Uganda instead.
That's right.
And I was returning to a clinic that is run by FIMRIC, Foundation International Medical Relief of Children. And they have about 15 clinics throughout the world. And the one in Uganda, I actually do believe I'm the only sort of actively practicing U.S.-based MD who goes there. There are a group of retired British physicians that go about once a year. And there's a Dr. Lukia, who's a Ugandan MD, who goes there once a week. But usually the clinic is staffed when I'm not there by Dr. Lukia once a week and by, I'll say, advanced practice nurses that are doing the consultations. And then so when I go, I try to go for a couple weeks at a time. And that's the Uganda scenario. Now, when I go down to Panama, I'll go for a week or two. Sometimes I've had the opportunity to go for longer, a month or more at a time. Like when I was in Nepal, I was there for about a month. And the clinics that I go to tend not to have a lot of resources like MRIs, CAT scans, etc. So ultrasound is used quite often in these remote settings, these limited resource settings. But the thing I always try to talk about is that sometimes patients will travel to a nearby hospital or maybe a town that's an hour or two away where you start to get access, if you have the finances, if you have the means, to these more expensive and advanced technologies.
With those weather conditions, it seems to me it would be very difficult for some vehicles to get people to the right place, don't you think?
You know, the nearby town, which I say is an hour away, actually, when I was there last time, getting back, it took 2.5, almost 3 hours to get from the town back to the clinic. So it can be really quite, a full day investment. And then, as far as major surgery, when I was there was one of the sons, this man had many sons of man in Damascus, who I think I mentioned was one of the wealthiest men in Bududa. He probably owns many cows. He owns a car. One of his sons had a hydrocele and had gone to the nearest town for surgery, and it had failed, and was looking at trying to get his son to the capital, Kampala, where there are pretty accomplished surgeons that can address it. So sometimes you have to travel quite far afield to get, and sometimes the surgery is done by local trained surgeons, and sometimes there might be groups that come in specifically to do surgery. I've got a friend who's right now in Madagascar, Fletcher Starnes, and he flies around. I actually ran into him in Uganda a year ago, and he's in Madagascar now, and he does thyroid surgery. So he'll fly in for a week or two with the team, anesthesia, and he'll do surgeries, and then they have to provide for post-op care.
The next one is from Rachel, who writes, I suspect it was Babesia microti. I suspect this was a different episode. Was there a recent Babesia-like case, Daniel?
There may have been, yeah.
So I would suggest that you put the episode number on your emails when you send them in so we can tell. Jim writes, greetings, brave slayers of the worm internal. Based on the information you provided, I would guess that the 2 patients have Ascaris roundworm infection. These patients live in a community where the soil and the water is contaminated by poorly contained human waste, which is spread further by its use in the local agriculture. Since the local climate favors several species of waste-friendly worms, we should consider the prospects of a co-infection with fellow travelers, such as whipworm or hookworm. Moreover, if water conditions in the nearby stream support the right species of snail, schistosomiasis might be endemic. Respecting the symptoms in this case, both patients have distended bellies. This could be an indication that intestinal worms are taking significant nutrients away from them. In the case of the older sibling, the evident degree of developmental delay is consistent with a long-term worm infection. Microscopic inspection of fecal assays is probably the best available way to determine which parasites are present and in what numbers. If Ascaris is the only parasite found, it can be treated with a single dose of albendazole. Unfortunately, unless community conditions change, eventual reinfection is likely. Happy New Year and welcome to the Roiling 20s. Take care.
Roiling 20s.
Jim in Vancouver.
Right.
Dickson.
James writes, Ascaris lumbricoides, a parasitic roundworm that often resides in the duodenum, or the duodenum, depending on which side of the Atlantic you live on. Somebody poops the eggs out into food/water supply. Then, on what one of my PEDS infectious disease docs called the fecal oral highway, we eat them. Then comes what one of my medical students thinks is pretty gross. The eggs hatch, the larva penetrates the duodenum and ends up in the lung. Then, in the grand circle of life, we swallow it, and it ends up again in the duodenum. Doesn't seem at all efficient to me. Works for them, though. Yeah, well, you can have a two-way conversation with them if you'd like, but I don't think they're going to talk back. Is it true that all 40,000 species of nematodes have 4 molts? Yes. Anyway, the adult develops, known to each other in the biblical sense, and produce knobby, often biliously stained eggs. Then the circle is complete, Obi-Wan. Differential diagnosis. I think it's too big and wrong syndrome for pinworm, anaerobius. I also doubt hookworms and whipworms. I guess strongyloides belongs on that list too, but again, I don't like that so much. Hard for me to believe the time of day matters all that much. The eggs are said to be pretty durable. Would the water in the tropics be less motile in the AM, allowing some settling? Can't really think of why. Here in Colorado, in the glacier-fed streams, perhaps the flow is a little greater later in the day. One of the immunology professors at Duke, when I was in grad school, told me that he had first worked with Ascaris, but became so violently allergic to it, and that's true. That happens a lot with people in that area. Allergic to it that he could not even walk into the lab anymore and had to switch projects. Since I am violently allergic to another invasive parasite, grass pollens in the spring, I can relate. Enjoying the podcast, I also enjoyed the STEM Talk episode and will be citing your pick, the stories about Toxoplasma, Trichinella, and Aceta for my medical students. He's a teacher, and that's great. So he's a teacher of pathology, and he did a good job of covering the waterfront, so to speak.
What's the STEM Talk? Is that something from your...
I believe, yes, I was a guest on a podcast for a STEM Talk.
Oh, yeah? What is STEM Talk?
It's a podcast that talks about science, and actually they featured me on their show, so I was quite honored.
Science, technology, engineering.
Exactly right. Exactly right.
Got it.
It's a Florida-based organization, at least in this one.
Well, Daniel, you get the pronunciation.
I know. Is this all from Andrew? This is going to be a challenge for me. Usually I mispronounce things so that Dickson can help me out.
But they give you a guide here, though.
Mary Kihirimeti. I like when they put because I don't know if it's k or h or r. Should that be a long I or not?
We don't know.
From Pongaroa. So we get a Merry Christmas greeting here in Maori. The weather here is showery, 24C, and cloudy. Book not yet won. Desperately trying not to fall into the gambler's fallacy. I think that's the fallacy where you think, well, if I haven't won yet, if I keep trying, my odds just keep getting better and better.
I think so, yeah.
My train of thought.
Dear.
Intestinal worms endemic in the Uganda-Kenya border region would be hookworm, Trichurus trichyra, Schistosoma mansoni, Ascaris lumbricoides, Entamoeba histolytica, E. dispar. The TWiP team discussed toilets, water, and diets quite a bit. Okay, I am thinking fecal oral route with maybe some sort of waterborne vector in between. A lot to unpack here. Hopefully an omen for me on Christmas Day. I start to look through my PDF of Parasitic Diseases 7th edition, looking for pink worms, but they all look pinkish and brown, so I start working on the size aspect. I change to the Parasitic Diseases YouTube channel and quickly find lecture number 24, Giant Intestinal Worms, and soon all the puzzle pieces fit the pattern for geohelminths and Dickson's Unholy Trinity. The salient points that lead me to deciding on Ascaris is its earthworm-like appearance, the failure to thrive syndrome, and the distended abdomens. The idea that there is a waterborne vector can be dismissed, and the eggs are being deposited in the soil by children afraid to use the long drop toilet, and the use of feces as manure. Mm-hmm. I had learned years ago that the distended abdomen in children was due to malnutrition, and that piqued my interest to find out more. Learning that the distension derives from kwashiorkor, a severe protein energy malnutrition that leads to edema. The name means the sickness a baby gets when the new baby comes. As the weaning child loses access to protein, ascariasis inhibits protein absorption by the host through the release of trypsin, a very sneaky trick. With a protein-poor, carbohydrate-rich diet, the children are going to get very little protein at all. I checked the other possible worms, but am sure a stool examination will show the presence of Ascaris eggs. Treatment. Ascaris should be treated before any other helminths found to be present, as an irritation might lead to aberrant migration within the body, leading to complications. Also, the village needs to be treated with access to proper sanitation and a diet with adequate protein sources, but that is beyond the scope of the case. 2 postscripts. 1. Sophie from Greece is my hero. My knowledge retention was better with the explanations, and the podcast was even more interesting than its usual high standard. As far as I am concerned, flights by scientists and educators should be subsidized or subsided. Which of those?
I think it was subsidized, yeah.
I don't fly anymore.
It means
I think he wants us to stop. I don't fly anymore, and will happily donate my saved carbon.
Yeah, so he wants to
subsidize our
with
flights with his carbon
I
donations.
understand.
Okay.
Namehe o te taho. Happy New Year in Maori.
Right.
Nice.
Can we address certain parts of this email, or are we going to wait?
No, let's do that.
I
I like
Okay,
to
so
jump in.
this is quibbles. My train of thought, intestinal worms endemic to Uganda, Kenya border region, and he lists hookworm, Trichurus, that's fine, Schistosoma, that's fine, Ascaris, but the other 2, Entamoeba histolytica and E. dispar, those are protozoans. So I would draw the line right between those 2 groups and say, or protozoans.
Yes, it's true.
And then Ascaris actually doesn't secrete a trypsin. It secretes a trypsin inhibitor, which then inhibits the host's ability to digest the protein meal. And the worm itself ingests what it needs to make itself produce 200,000 eggs every day for 5 years sometimes. And in doing so, it inhibits the host's ability to digest the proteins and grow as a normal person would without the worm infection. So just those 2 little things. But other than that, it was an excellent answer.
All right. Thank you, Dickson.
You're welcome.
Ben, Right.
I was going to comment
yes,
that. So just to get us back to Ghana again, I guess I keep mentioning Ghana. So yeah, the translation kwashiorkor is a word from the local Ghana dialect.
Oh, interesting.
So that's where that came from. But yeah, the sickness
And where
that a
does
baby
marasmus
gets.
come from?
Marasmus. I actually think that's like Greek.
Is it?
Yeah, I'd have to look it up, but yeah,
Right.
I think so.
Ben writes to the TWiP DVD, Dickson, Vincent, and Daniel.
That's great.
Firstly, congratulations to Vincent on starting up a new podcast in Twin. The small amount of neuroscience I got in my undergraduate degree was too dense, and so I tended to switch off, but I'm finding Twin very appealing and easily digestible.
Nice.
Excellent. Thank you very much. For this week's case, I would say it is likely that the 1-year-old boy is infected with Ascaris lumbricoides. No other worms come to mind of that size and shape, and it would fit the setting well. Having said this, infection with A. lumbricoides would occur had the boy come into contact with human feces, and it may be the case that he is also infected with other soil-transmitted helminths.
Mm-hmm.
It's likely that his older brother is also infected with A. lumbricoides, given the protuberant abdomen. It seems most likely that both boys are infected with A. lumbricoides and also trichuris and possibly hookworm, and that these soil-transmitted helminths are acting combinatorially to cause the delayed growth seen in both children. It is possible that this could be compounded by malnutrition, but I wouldn't think, based on the description of diet given by Daniel, that this would be sufficient to cause such significant growth stunting. Albendazole and mebendazole treatment would likely be effective for all three of the soil-transmitted helminths mentioned. Without improved sanitary conditions or continued routine deworming, unfortunately, these children will probably become reinfected again in the future. It is currently a sweltering 42 degrees Celsius in Adelaide, South Australia, and we are set for a week of days above 40, which is not very good news, as an area larger than Maryland has been completely destroyed by bushfires already this year, just in the state of New South Wales, in what will likely go down as by far our worst bushfire season in history. Yes, we have been hearing about that, of course.
Yes.
Yeah,
And since you have written, it's gotten worse.
Mm-hmm.
It's true.
Thank you all for another great year of podcasting and wishing you all the best over the holiday period. Thank you, Ben.
Right. I have a friend who lives down there. His name is Roland Scully. He's a friend of mine, and we often trout fish together in various places. And he's got a brother and sister who live up on the Gold Coast of Australia, below Brisbane. And they actually had to retreat to the ocean in order to get out of the way of the fire that went right down to the beach.
Wow.
Yeah, they were both okay, but unfortunately about 20 people have died. But they're thinking about the wildlife losses.
Huge.
The koala bears, they're very slow animals, and they can't get out of the way of any of this.
Pictures of all damaged koalas trying to treat them.
Absolutely.
They're going to get wiped out.
It's so sad. Okay, back to our regularly scheduled program. Cecilia writes, Dear doctors, thanks again for your podcast. I think the two boys, the 15-year-old and the 1-year-old, are infected with Ascaris lumbricoides. The younger brother is known to be passing worms that fit the description of Ascaris. The older brother is not able to visualize the worms due to the type of toilets used in that part of the country. As stated in PD7, in some regions of Africa, up to 95% of the population can be infected by Ascaris. This can be due to poor hygiene and the ability of Ascaris eggs to survive in the environment for long periods. Ascaris is spread by ingesting the eggs that have been passed in the feces of an infected person. Both boys show signs of infection as well, the youngest having a distended abdomen and the older, by his short stature, appearing younger than he is. As stated in PD7, a 400 milligram dose of albendazole or 500 milligram dose of mebendazole is effective for deworming. There is so much information on Ascaris infection that I'm sure you other responders will include. I look forward to your next podcast. Sincerely, Cecilia. Yes, she lives on the west coast of Florida.
We got that right.
And there's a little note for you, Daniel, there that we don't have to.
That's kind. Thank you.
Right.
Daniel.
All right. Peter writes, Dear Doctors of TWiP, the description in TWiP 178 really had me scratching my head. That's usually a comment we get when someone has scabies or something, but let's review the facts. 1. A 1-year-old with evidence of slowed physical development accompanied by their 15-year-old brother with the same problem. 2, enlarged belly in the 1-year-old and similar sign in the 15-year-old. 3, 2 descriptions were given. Firstly, the 15-year-old boy mentioned a long, flat, white worm. Daniel described the picture in the Parasitic Diseases 7 as showing a pinkish, almost fleshy-colored worm that is 8 inches, about 20 centimeters in length, and round. The description of a large, round worm in distended abdomen immediately brings Ascaris lumbricoides to mind. None of the images in PD7, however, show a pinkish worm, unless one counts the illustration on page 206 and a few of the individuals in 18.7. The predominant color seems to be a yellow or beige. The trematodes, fasciola, and clinorchus are pink, but neither round nor large enough. This color does align with the boy's description of the worm as white, though. The enlarged belly could be due to Ascaris lumbricoides as a bolus from the heavy infestation of Ascaris worms, roundworms, and could cause both the enlarged abdomen and impaired growth reported. Then again, Schistosoma mansoni can cause hepatosplenomegaly, enlarged liver, and spleen, which might explain this symptom in the young boy or his older brother. S. mansoni could also cause physical development stunting, as could hookworm, most commonly Necator americanus. In addition, PD7 notes that the STH, soil-transmitted helminths, Trichuris trichiura, whipworm, is often found together with A. lumbricoides, and that children suffering from heavy trichuriasis develop chronic malnutrition, short stature, anemia, and finger clubbing. The symptoms are thus nonspecific, so I would consider epidemiology. Moses and Drico et al. Note that mass deworming campaigns have reduced the incidence of STH infection from over 60% in most districts to less than 9% in 2016. Of the remaining cases of STH, hookworm is the most prevalent infection, about 7.7% of children, followed by whipworm, 1.3%, and roundworm, about 0.5%. Schistosomiasis impacts some 13% of children. Perhaps the details of STH is plaguing the children is less important than what to do about it. Albendazole and mebendazole are recommended for treating helminthic infections, although their correct choice of drug and treatment regimen will depend on what is practical in the setting. For schistosomiasis, praziquantel is recommended. I realize that I've digressed quite far from the original description of a worm in this discussion, but given the lack of opportunity for detailed diagnostics, it seems prudent to pay attention to the parasites unseen as much as to the parasites that was seen by the 15-year-old boy. While reinfection is always possible, even likely, the Andrico paper gives me hope that public health interventions in the country are gaining ground. And then we get some references here. And then Peter, writing from my home base, a rather rainy Cape Town for once. And P.S. Vincent asked about feeding mosquitoes. I enclosed below a photo taken in the insectary of the University Clinical Research Center at the University of Science, Techniques, and Technologies in Bamako, Mali. The glass vessel is fed with warm water to keep the apparatus at human body temperature. Infected blood is inserted into the central tube, which is closed at the bottom with parafilm, and mosquitoes are in the box attached at the bottom. Similar facility I visited at CERMEL in Gabon had a simple cup full of mosquitoes. They say one challenge at UCRC is acquiring the blood. It is unethical to entice one's students to donate blood, given the student-supervisor relationship. So the university is forced to compete with other users of the local blood bank for human blood. And then he's got some interesting photos here, which I think will be up in the show notes.
Mm-hmm.
Okay.
He might know Bob Gladz, because one of the authors of our book, because Bob spent a lot of time in Bamako, and so did Dr. Sakai, who was his colleague while he was overseeing some projects with regards to malaria surveillance. And I think in order to find out which mosquito species are guilty of this, they had to set up an insectary, and so that's where this might come from. So there might be a nice connection there. Just a thought.
He has a suggestion for a future hero.
He does. Professor Adulai Jimde,
okay.
Bamako.
All right.
So Peter won a book.
Yeah. I think he won a book before, and now he's moved from Nigeria to South Africa.
Yeah, which is okay because I haven't sent it.
Right, but you will. I know you will.
Said winning the book has been a highlight of his month, and his eldest kid has already informed him that he's going to steal it.
Oh, dear.
Awesome.
Oh, dear.
All right. Oh, Kevin.
Who got Kevin?
I got Kevin.
He did. He got him.
Manson's Tropical Diseases, 1923, in the chapter on Ascaris, describes them as verminous visitors and troublesome guests. This has an almost a holiday flavor.
The worm who came for dinner.
The two brothers in this case are infected with Ascaris. A large pinkish intestinal worm could really be nothing else. They may be co-infected with Chicurus and hookworm as well. A trifecta of soil transmitted helminths. The differential diagnosis in this case spills over into the social and economic realms. The protuberant abdomens and stunted growth suggest chronic protein-calorie malnutrition. Poverty and unbalanced nutrition are likely the principal culprits in the poor condition of these children. Though not innocent bystanders, the Ascarids are probably just adding insult to injury. It is likely that the majority of children in their village are infected, but our patients may be at the low end of the social strata with a more precarious existence, perhaps orphans being raised by a grandmother. Treating these boys with albendazole will likely remove the infection temporarily, but reinfection is inevitable. If their worm burdens are extremely high, perhaps their overall condition will show some improvement. On initially hearing case 178, I thought that individual treatment and mass deworming were equally intuitively obvious, a case of common sense, something that just stands to reason. The picture became more murkier when I read some of the literature on STH-MDA, mass drug administration, and their effect on nutrition, cognition, and growth. The Cochrane Review of MDA, recently updated September 2019, and summarizing 50 trials involving over 84,000 children, concluded that deworming programs do not appear to improve height, hemoglobin, cognition, school performance, or mortality. The Cochrane also states that there is very little evidence that body weight, physical fitness, and school attendance is improved after deworming. Added to the disappointing effect of deworming on multiple outcome measures is the possibility that deworming could increase susceptibility to malaria infection in children. The consensus opinion is that MDA for STH does not increase malaria infection. However, complex interrelationships of chronic helminth infection and immune function leaves open the possibility of unexpected consequences of mass treatment. In a 2014 review, Howden argues that mass drug administration for STH is an unsustainable strategy and instead advocates for the use of biogas latrines. But this solution brings up the entire topic of the sociology of defecation and the acceptance of latrine use among traditional people. Flies again appear in the ointment regarding the uptake of latrine use in traditional rural societies. This curious topic is briefly discussed in endnotes. In summary, of course, the two boys should be dewormed, if only to prevent the more uncommon consequences of intestinal obstruction, biliary invasion, or extra-intestinal migration. The effect of one-time treatment, however, is likely to have dramatic or long-term benefits without the addition of more diffuse remedies, such as widespread sanitation, mitigation of poverty, and improved nutrition. Wishing the trio of worm mentors a very auspicious new year.
Right.
And then we have endnotes, and I highly recommend that you go to the show notes at microbe.tv/TWiP to read some of these because they are absolutely entertaining and informative.
Indeed.
And for example, I will just point out some highlights. I want to mention the Game of Thrones leader of the Army of the Unsullied Grey Worm. I didn't know that because I never watched it. That's very interesting. We have a little bit about growth stunting, Ascaris, and nutrition.
There's a nice reference to Mike Schultz, and we featured him last time on Heroes.
Mass drug administration for STH, which we briefly summarized, deworming and malaria infection, and then a terminal curiosity for the people of the non-epidemiologist persuasion in high-resource nations. Excretory practices are fairly standardized and not subject to a great deal of discussion. The idea that open defecation would be preferable to a latrine or outhouse seemed unimaginable before I read a few papers on the subject. I have also appended a few notes on the intersection of religion and defecation, as well as the role of superstition in toileting. Very interesting things here. We have a website called toiletguru.com. Historical toileting practices. And there are all sorts of traditions here about how to defecate. And then the last point is from the Department of Parasitic Haberdashery. We have a parasitic nematode worm.
We do.
Under the microscope miniskirt.
This is all true.
I thought that was awesome.
Designed by Zosimus.
Looks like Wuchereria inside of a nodule. Or inside of a...
No, I think it's actually Ascaris, right?
Is
it's
it?
Ascaris cross sections. Yeah, so you get the cuts like that, right?
That's what he says it is.
Yeah.
Okay.
And it's only $30.77.
And you could be wearing a parasitic nematode
You
miniskirt.
could.
But it's a little too short. My girls cannot wear such short skirts. So do not
It's
approve.
very short. It's mid-thigh length. Yes. Thank you, Kevin, as usual. It's lovely. I love the
That's
skirt.
great.
I've never seen a parasite worm skirt before. I've seen all kinds
Nor
of other
I.
things.
Yeah. And I hope people realize that my children don't listen to me. I can tell them what they can't wear all day.
Yeah, that's right.
Nobody-
No, come in with just the opposite.
Dickson,
I
you're
hear
in
about that.
They say, yes, Daddy.
Right. Let's see. Western University Global Health Track students, Dana, Stephen, and Chris write. Hello, TWiP professors. Thank you for providing such interesting cases. We believe that for this month's episode, Ascaris lumbricoides is most likely the parasite. We came to this conclusion mainly because the worm described was about 8 inches long, round, not actually flat, and pink, and this directed us towards a large roundworm. For treatment, albendazole/mebendazole could be used. Sincerely, Western University Global Health Track students, Dana, Steve, and Chris.
And that is it. There's our 11-ish, with a few excluded because they won books already.
Right.
And
So
most
now
of them...
we need to raffle it off.
What did you think, Dick?
Well, I thought all of the answers were thoughtful and paid attention to the presented data so that they didn't drift outside except for that one Babesia flyer, which probably was a response to an earlier case. And a lot of them had good things to say. And even when they got some things wrong, they got it wrong in a direction that allowed an easy correction. Like, for instance, Ascaris interfering with trypsin and stuff like that. So it brings up a lot of interesting points. And of course, the bottom line, of course, no pun intended, is that if there's no sanitation, then there's no health.
Mm-hmm.
That's the really issue. That's the biggest issue.
What did you think, Vincent? You've been around the block for a while here.
Indeed.
I've
We've
been
even
around the
brought in
parasitic block.
Was it a
We could bring one in for you.
Is
if
that
you'd
a
like to see
para-
pink one.
Is that a paraffin block
Exactly.
there?
That's right.
Yeah, I thought this was clearly Ascaris
Yeah.
from the size and
Yeah, that's right.
but I like that some of the listeners are adding other possible co-infections, which makes sense, right?
Exactly right.
I thought that was great. That's actually what I, really liked to
Yes.
have my favorite email person. But the fact that people brought up if there's Ascaris there,
Yeah,
and then I think we're sort of immortalizing Dr. Brown, right?
Yeah,
I was just recently reading a book by Peter Hotez, and he attributed the unholy trinity comment to Dr. Brown, as I think Dickson has often done. If you've got Ascaris, you probably don't just have Ascaris in these areas.
No, that's right.
And so we'll often treat, instead of just the one dose for Ascaris, we'll do 3 doses. And then we also want to find out, why are you not, participating in the deworming programs? And FIMRIC is now involved in the deworming in the Bududa district of Uganda, because if you treat these kids once, they're going to get reinfected. A single female adult Ascaris puts out 200,000 eggs per day.
Yep.
We estimate. I mean, that is just
It's amazing. Isn't it?
phenomenal. So here, each of these boys has multiple infections. We're talking about millions of Ascaris eggs.
That's right.
Hardy Ascaris eggs, which are going to embryonate and then be all over the place.
Yep.
So reinfection is the rule. And so you need all the things that people mention. You need to treat the Ascaris now. You need to treat the co-infection worms. You need to be involved in a deworming. But yeah, sustainability, you've got to improve sanitation and hygiene. That's always why it's the tropical medicine and hygiene.
Yep.
Mm-hmm.
there's so much going on, and you can cure so much in a hurry with this single step of good hygiene that it's a shame that it's not an easier fix than it turns out to be in some areas.
I just want to point out page 221 of the 6th edition.
Okay.
Which is the Ascaris chapters. Most commonly, individuals become aware of the infection through casual examination of the stools because of passage of an adult worm.
Yeah.
Yeah.
They come out.
Yeah. Yep.
Yeah, they do.
So there it is. Right there.
It's interesting. I think we've probably talked about some stories about it is a challenge. They all just go in. We'll have this project. We'll build a whole bunch of toilets. All the problem will be all solved. But there's a couple issues. One is, you do want to be a little careful with a 1-year-old and 9-month-old. You do not want them falling into the abyss.
Yeah.
So these kids are going to be out there putting dirty hands in their mouths in the cycle of reinfection. So unless everyone's using toilets, unless everyone's washing their hands when they're involved with really young children, it's a problem. And then I think we've told some stories. There was one story where a group went in and they built these latrines, and it was going to be so great. And they did science, right? So they did studies ahead of time, and then they went back to do the studies afterwards, and they found that the worm burden, the number of people infected, had actually significantly increased.
Right.
And what it was now that people are like, oh, this is great. When we want our fertilizer, it's all in one place.
This is true. That was the Engineers Without Borders from Colombia. As a matter of fact, that's where I got that story from.
Yeah.
Trish Culligan was the engineer in charge of that particular study of composting toilets, and they never allowed them to get to the stage of composting. They just used them as a collection device.
Perfect name for that. Culligan Man.
Exactly. Collier Culligan Man. That's right. Well,
so, Daniel, what did you do with these boys?
So we treated them for 3 days, as mentioned. So they got the 3 days of treatment. Yep. But then we also talked to them about making sure they were part of a deworming, a regular deworming. So we'll be having, just to make sure it happens, we talked about come back every 3 months, and we're going to make sure you get your deworming medicine.
Right. So a lot of these deworming programs take advantage of the fact that kids go to school and they do it while they're in school, but these are preschool. These are preschool age. Well, at least one of them was. So
pre and post school, right? So the 1-year-old is pre, and the 15 is post, actually, in this area.
So they may miss the boat on that one.
Yeah, and with the issue, you have to pay your school fees. School is not free; it's not free public school.
Right.
And so the 15-year-old from this family, it sounds like he's not going to be someone that the family has the resources to pay school fees for. So.
When you give these drugs, what happens to the worms that are in the kids?
It's interesting, and it's different from the picture that we show in the book. We used to give. We'll say these older medicines that would paralyze the worms, and then the worms would come out. Yes, the piperazine citrate would actually cause all the worms to just be expelled, semi-paralyzed. A lot of times with the albendazole and mebendazole, the worm will actually be killed. It interferes with microtubules, and then it will actually be destroyed. And you're not seeing this dramatic.
Got it.
So there's a crossover piece of information here that you might be interested in, and you may want to feature it on your twin. Because Ascaris, the reason why that guy at Duke was allergic to Ascaris, because they produce something called ascaricidin, which is an allergen. I believe it's a volatile allergen, so that it gets into the air, just like mouse dander. But why was he studying Ascaris? And the answer is that Ascaris is a very large worm. It's 8 inches long, basically. And so you can actually put that on a dissection tray. You can cut the worm down longitudinally and expose the entire innards of the worm. You can scrape out the gut tract and the intestinal tract, and what you're left with is the nervous system of the worm. And they have very large nerves. So you can study neurotransmission in this parasite, and as an example of an invertebrate nervous system. Cool. So a lot of people do work on it, and it does happen that a lot of them develop allergies as a result.
How do you grow these worms? In what?
Pigs. They're pig Ascaris. Yeah, Ascaris, they collect them from the abattoirs, the local abattoirs.
So if I went to an abattoir today, I could find
no problem.
Really?
Unless they've all died from swine fever.
No, but so how do people not get infected?
Because they don't infect people mainly.
But we are eating pig ascaris when we eat pork.
No, we're not.
Because we don't eat the intestines, right?
No, but you don't eat the eggs. The eggs have to incubate in the soil for a week.
Yeah, I understand. But still, the material. But it's not in the muscle, which is what most people eat, right?
No, absolutely not.
Now, if someone ate pig intestine, they might be eating some worms, right?
It still wouldn't infect you.
No, I know it wouldn't infect, but you're eating worms. This simple fact on its own might disgust some people.
When you eat your worms, make sure you chew them well.
Right.
So we give away a book?
Sure. We do.
You bet.
And I tell you, everyone out there who I owe a book, I will get them to you before 30/30. I will get them to you this year. I have a few deadlines early this month, but I will get them to you. Okay? I promise. My promise is good, right? So we had 11 guessers. Let's pick a random number between 1 and 11. Number 11. Generate the number 4. You know, I could cheat and just give it to who I want to, but that wouldn't be
Yeah, we can't even see the screen over there.
No,
it is 4. It's 4, and 4 is Courtney. Courtney.
Oh, yeah. Good.
Who asked about your travel logistics.
Cool.
Can't really tell where Courtney is from because there's no Colour, Colour, you know, which would give it away. So Courtney, send us your address at TWiP@microbe.tv. If you happen to be out of the U.S., then we'll need a phone as well for putting on the form. So please, Courtney, you are the winner. Congratulations. And as I said, we'll get yours and others out soon.
Right.
Soon.
Roger that.
All right, let's do a paper.
Right.
We have a paper selected by Daniel this month.
We do.
We each take turns selecting papers, although you can't really predict because it's kind of random. But it's
a good paper.
It's interesting. A primate model of severe malarial anemia, a comparative pathogenesis study. This is in Scientific Reports, which is open access, so you can see it. And the first author is Amber Raja, and the last author is Patrick Duffy, which is a good name. Isn't there a Duffy antigen?
I wonder if he's related. That was my first thought. Is he related to the Duffy antigen?
Right. And this comes from a number of NIH labs and London School of Hygiene and Tropical Medicine and Weill Cornell Medicine here in New York City. Now, apparently, that malarial anemia is a big problem, and it may be a major cause of death. Tell us about that, Daniel.
So this is true, and severe anemia, and by severe we define it a little bit differently in children and adults. We have thresholds, and so you can do it by hemoglobin, which is sort of measuring the amount of hemoglobin, or we could do it by the hematocrits, where you actually spin the blood, and the plasma will be at the top, and then the red cells will be at the bottom. And those you can do pretty quickly. We used to do them in the emergency room when we were doing trauma over at Bellevue. And for children, we'll say the hematocrit less than 15% would correspond. Normally, it's going to be about 35-40%. And in adults, it's going to be less than 20%. The big issue here is you're going to have a really dramatic reduction in your oxygen carrying capacity. And the interesting thing is, people always think, oh, well, malaria, it's in the erythrocytes. It causes them to be destroyed. That must be what drives this mechanical explanation. But really. Over 90% of the red cells destroyed in malaria are not parasitized.
Yeah,
that's right.
And so that explanation doesn't quite work.
Right.
And so here we're looking at, well, what is it? Right. What is it that... Okay. Mechanism potentially behind this severe malarial anemia.
Right. So they use a plasmodium species I've not heard of. Coatnei. Yeah. How do you say it?
Coatnei.
Coatnei.
Yeah, Coatney was a malaria researcher at Tulane University.
And this is because they infect non-human primates? Is that why they use that?
They infect non-human primates is exactly right. And so they've got two different species of non-human primates with the same parasite to look at the relationship between the sequestering of diseased blood cells, red cells, and there's a protein called CD35, right? And that supposedly prevents complement from lysing cells. If you're coated with that protein, it inhibits the complement from cascading onto the surface of any cell. And it turns out, as you'll read on, that plays a big role in the outcome of this study.
Now, the monkeys, they use rhesus and cynomolgus macaques.
Right.
Macaca mulatta and Macaca fascicularis. They're not infected by, say, falciparum?
Apparently not. But this is a lookalike parasite.
Okay, so it's a model.
That's right.
All around. Okay.
That's right.
So the purpose here is to find out if these animals would be a good model. And if so, can we learn something about what makes the anemia during a malarial infection?
Exactly.
Right?
Now, I remember some older studies when I was at Rockefeller, not studying malaria, but everybody else seemed to be studying it. There was a gentleman there who was looking at something called osmotic fragility.
Yes.
To see whether or not the red cells in general were affected by some, let's say, substance that the parasite was producing that got into the blood and then caused all of the red cells to become, less isotonic at the normal saline concentration in normal blood. And he was able to show a relationship. His name was Edward Platzer, as I recall. And he was a very interesting guy in his own right and ended up at UC San Diego, rather. Sorry.
Now, a few words about these animals. These are part of the colony at NIH. They have a breeding colony. The rhesus macaques are of Indian origin, and the cynomolgus are from Vietnam. And cynomolgus macaques were essential in development of the polio vaccine.
Is that
by
right?
the way.
Yes,
Yes,
great.
they can be infected with polio. But these are older monkeys. They're 4 to 6 and 2 to 12 years old. They're old. Now, here's something I wanted to ask you about, Daniel. They're immunized against measles. Why is that? Do monkeys get measles in colonies?
This is past my pay grade. I do not know. Do we have a virologist that we could ask?
We probably have one sitting right opposite us.
I suppose they must get measles. I don't know where they would acquire it, because the handlers should all be immunized, right? And they're bred there, so I don't quite understand. So the fact that they're immunized must mean that they can be infected, right?
Yeah.
But what the risk is very interesting.
I'm trying to remember the history of this, and maybe you remember this, because weren't there colonies, and there were a lot of the early viral studies down in Louisiana? There were.
Yeah, there's the Yerkes, or was it it was in CDC.
Yerkes is at Emory.
That's right.
The Yerkes Primate Center is at Emory.
Yeah.
But so these monkeys can be infected.
With measles.
Yes. But I'm not sure that's why they're immunizing them. I bet there's a better reason, and I just don't know.
They don't want them to give it to us.
No, it's something else. I don't know. Anyway, that's one thing. And the other thing is, these animals were provided with hanging and floor toys with perches and cages for exercise.
Right.
And so it's very interesting. When I was in Galveston, they have a big primate colony there, and they show them videos all day to keep them amused.
Really?
Yeah.
Oh, interesting.
Because he said, you know what those videos are for? I don't know. The staff are looking at it. He said, no, it's for the monkeys.
Keeps them company.
Because they're close to us,
I'll be darned.
Well, the whole animal enrichment, right?
Yeah.
That's a big part.
Yeah, well, knowing what their normal environment's like, though, this is a far cry from that, isn't it?
Oh, the jungles are great. You could be eaten any day by a lion or whatever is in these jungles. There are no lions in India, right?
There are no lions in India.
There are tigers.
in
There
India.
are tigers in India.
But look, I think
Vietnam
if
also.
you gave these monkeys a choice, they'd rather be out there in the trees, in the canopy.
No question.
Is that a good monkey sound?
Inhabiting some temple.
I think monkeys are the coolest.
They are. I agree with you.
I just think they're awesome.
When I was in Morocco, there were the barber monkeys. They were on both sides of the Straits of Gibraltar.
Okay. Now, Daniel, they put the parasites intravenously through the saphenous vein.
Yes.
Where is the saphenous vein?
Down in your leg, actually.
It's a leg, the inside of the leg there?
Inside of the leg, yeah.
Nice.
So it's just, I think it's more than anything, it's an easy to access intravenous site.
All right. So then they inoculate, and then they measure different things over like 15 days.
So it's not a mosquito-borne infection.
No, it's not. But it's put into a vein, which of course a mosquito would not do. It would put it in a capillary, right?
That's correct.
But you make a viremia, not a viremia, parasitemia.
Sporozoitemia.
Sporozoitemia.
Correct.
Yeah, you're putting sporozoites in, right?
In this case, they're not, though. They're just using infected blood to infect with. So the erythrocytic stage is the
freshly thawed P. cotinei infected RBCs.
That's right.
Yeah, which is actually slightly different. And there was another recent paper which that was interesting, which was about, we always talk about hypnozoites.
Oh, yeah.
So every so often in New York City, we have a case of malaria that is IV drug user, right? Someone shares a needle and then you end up actually bypassing the liver phase.
That's right.
And so you're going right into the RBC phase. So
interesting.
So, people could make a comment that this is a slightly different type of infection than we're seeing, as you point out. Normally with the capillaries, with the sporozoites, it's going to go to the liver. That's about a 10 to 15 minute time period. And then later, it's going to go from the liver.
About a week later,
it's going to end up in the RBC,
in the blood,
or the erythrocytic phase. So we're throwing in erythrocytic phase.
I don't think cotinei has a hypnozoite stage, but I'm not certain.
No, so I don't think it does, and that was what I was saying. It's sort of an interesting paper. We always talk about Vivax having a hypnozoite stage. And then the data's been a little thin on Ovale, but now we know there's two different types of Ovale, right? There's a Wallacari and a Cortese, if I'm pronouncing those. And it turns out only one of the subspecies has a hypnozoite and the other doesn't.
Interesting. But they were using this as a falciparum lookalike.
Exactly. So we're not actually that worried about the skipping of the liver.
No, we're not.
So they have 4 of each monkey. And these monkeys don't show any respiratory distress. They have no prostration. They have no convulsions. So they're okay. But then they do have parasitemia.
They differed in their responses.
They have parasitemia, which happens every 2 days.
Exactly.
And what is that called, Dickson?
Well, there's tertian and quartan.
They call it tertian.
They call this tertian, but actually falciparum is
quartan.
I believe so.
And the rhesus have higher parasitemia than the cynomolgus. They look at hematocrit,
right?
Which
they did all the blood work
goes down, but more so with the rhesus.
That's right, because of why?
So more parasitemia, more anemia.
What's going on here?
Well, we're going to find out. Maybe we're going to look at some parameters.
You're going to tell us?
Wow, we're going to go through the paper. They look at bilirubin. Why would they look at that?
So that I think there were 2 parameters. Maybe this will help people to get through this. So when you lyse a red blood cell, you release bilirubin into the blood, and you can measure that. The other thing you can also measure is something called haptoglobin, which they measure, and that gets bound up and decreased. Right. So bilirubin goes up with lysis of red cells. Haptoglobin goes down.
Huh. Can I just ask a point of qualification? I thought that bilirubin was produced as a result of the degradation of hemoglobin.
Exactly.
Okay.
So as the red blood cells are destroyed, then you're going to end up with a process, and you're actually going to conjugate the bilirubin, right? And that'll allow you to secrete it in the biliary system.
And that's why your stool is that color.
Yes. Yeah, if you block that, your stool actually turns gray.
Exactly.
Yeah, so if you ever have gray stool, it's because you're not getting
So it's secreted via the liver through the gallbladder out into the small intestine.
Exactly.
Bingo.
Yeah.
They also measure creatinine. Is that for liver function?
Kidney function.
Kidney function.
Kidney function.
And it seems to be okay, right?
Yeah, there's a little bit of a difference we see between the two.
That would be looking for immune deposits, so to speak.
So as you end up having, as you have kidney compromise, your creatinine will go up. So as creatinine rises, your kidney function is going down.
Right.
And then they measure platelets.
Yeah.
Which go
down, and then they
go up. And what is that telling us?
So that's another one of the things we see as part of the immunological impact of malaria. We see anemia, so red cells going down. We see, neutropenia, lymphopenia, so all our lymphocytes and neutrophils are going down, and then platelets, thrombocytopenia. We tend to see a significant drop in the platelets.
Okay.
Are we looking at a bone marrow depression type of situation then?
Well, that's the interesting issue that we're getting into here. Is it that you're not making these things? Are you
Right.
failing to make red cells? So is it your erythropoiesis index, or are you destroying them, right? And we think you're destroying them because we're seeing bilirubin's going up, haptoglobin's going down. At least part of this is destruction.
Mm-hmm.
And okay.
And they're going to
prove I read the discussion.
And they're gonna claim that the destruction is in part potentially mediated by the complement system.
Mm-hmm.
Right. But they also had a speculation that the bone marrow might be producing the right cells, but they can't get out into the circulation because there was some structural change to the bone marrow as a result of having to suddenly produce all these reticulocytes. Yep. At least that's what I thought I read.
Yeah, no, and we refer to that as ineffective erythropoiesis. So you're making the red blood cells, but you're not doing it effectively. So you're not getting them out into the system.
Okay.
So they say the rhesus is the only one that developed severe anemia.
Yeah.
Right.
Yeah.
And
so they're more human-like than the other.
Well, I don't know, because this is not a human.
No, but they were comparing it to the human, the children.
Right.
Yeah, they're using the rhesus as the model of severe malarial anemia. And then they're, I think, asking a pretty good, is there something different between these two?
It has to be.
And
it might be a host susceptibility difference that it's so slight, but they're still different.
So the first thing they look at is parasite accumulation in deep tissues.
Mm-hmm.
Right.
They say microcirculatory obstruction has been associated with severe malaria in people, right?
That's a falciparum-like syndrome.
And they find it's similar in the two monkeys. No, so it's not correlating with the
and it's a good thing that the megakaryocytes are down. Otherwise, the blood would clot because it's stasis, right? So maybe that's a feature of the parasite's ability to keep the host alive.
They look for hemozoin,
right?
Which, again, remind us this is a byproduct of hemoglobin breakdown.
It is.
Right?
It's the heme groups stacked on top of each other like they would in, let's say, a malaria-infected red cell. Only in this case, it's what results after the parasites break out of the red cells. It's the leftover product from their destruction of the hemoglobin.
Okay.
The heme groups are totally useless to these parasites. They just want the globin part.
So they say they see similar hemozoin in the two models.
And it's called malaria pigment. Another way to look at that is it's called malaria pigment.
Yep. So is that right, Daniel? They find the same amounts of...
Yeah, they didn't see much difference.
So they say that hemolytic differences between the two models not due to extravascular hemolysis of infected red blood cells.
Yeah.
Extravascular meaning in tissues, right?
So extra versus intra.
Uh-huh.
Okay. Bone marrow. They saw hemozoin in the bone marrow, but they didn't find parasites in the bone marrow.
Right. Right.
So it can be, you can get hemolysis in the absence of parasites, right?
Or you don't have mature red blood cells, so they don't infect them.
Mm-hmm. Okay. Hemolysis in both species, consumption of haptoglobin, which we talked about, which is binding to free hemoglobin, right?
Yeah, it's interesting. And now sort of figure 3 when we start to look at haptoglobin. So haptoglobin we see at about 10 days post-infection. You see a really big drop in our rhesus.
Right.
But then the other side is you're not making a lot of reticulocytes. And your erythropoietin, which is a protein that should be driving this, it really goes up in the rhesus, but it's ineffective. You're not seeing it result in the reticulocyte. And reticulocytes, for our listeners, are newly produced red blood cells. And the way you recognize them is they still have a little bit of nuclear material. They're a little larger. So
the haptoglobin goes down, as you say, but the cynos don't have a comparable decline.
Mm-hmm.
And they say this suggests the infected rhesus experience exacerbated hemolysis compared to the cynos, which likely contributes to the severe outcome. And this low erythropoietic response that you mentioned is, they say, is also a feature in children, infected children. And so rhesus display a greater defect in erythropoiesis, failed to mount a proper response, which may be part of the severe anemia, I guess, right?
Right.
Yeah, I mean, it looks like they're getting hit both sides. They're unable to effectively replace the red cells, and they tend to be having the red cells. It looks like we're seeing intravascular destruction of red blood cells.
But then you have to go to the mechanism of red cell destruction.
Okay, so now they look at cytokines and chemokines. Right? Immunological markers.
Yep.
CD35, which is a complement regulator.
I looked this one up in Wikipedia because I didn't know what it was. And it was very complicated story of how it actually works.
Well,
And
it's
the
a complement
IP10
regulatory protein, right?
Indeed it is, but just how it does that, it's kind of fuzzy.
Well, I think it blocks complement. So
It prevents the cascade. That's
so
right.
if you don't have it,
You either don't get attachment of complement or the two factors that have to be present
right,
to poke a hole into the cell doesn't come together.
and that was the one that was lower in rhesus compared to cynos.
Exactly.
So maybe it's correlating with the destruction of.
So the rhesus is more human-like than the
cynos. Mm-hmm. They're both cute, though.
They're adorable. They are adorable, except if they bite you because they've got big fangs.
Yes.
They do?
They do.
Okay.
I don't know. You guys remember Mike Metzger, who used to do the bivalve?
Yeah, I do.
He had one of his mentors was in Africa, was just showing how comfortable he is around one of the monkeys, which proceeded to then bite the tip of his finger off.
Off?
Actually bit the tip off. So.
Wow.
So monkeys, gotta.
They look.
I mean, you see baboons chasing each other. They're not quite monkeys. They're
Do you
something
make
else.
a monkey noise, Dickson?
Yeah, I don't do monkey noises, just to warn you ahead of time.
They also looked at whether there's uncontrolled inflammation contributing. They looked at 18 cytokines and chemokines.
Yeah, and they did. They saw some differences.
Yeah.
Between the rhesus and the cynos, which is what you're looking for here, because now you can compare the two, I suppose.
And then some difference in the activation of CD4 T cells using
T cells
CD69.
as well. Yes.
So
now, if you want to know what these things are doing, you'd have to start doing depletion studies, right?
You would, and I think that was my one thing I would have liked in the study is some way of testing the mechanism, some way of maybe adding CD35 or some way of interfering with the complement system to really pin down, so a correlation to much more of a pinning down a mechanism.
Right. But we have a few hints here from this, right? We say the rhesus now develop anemia. They have more substantial hemolysis and poor erythropoiesis, and maybe the CD35 and the particular cytokine chemokines are involved as well, and maybe some T cells, right?
Does this suggest a intervention strategy, though? So that can you induce more CD35?
Well, that's a good question. Their last sentence, Dickson. Their last sentence is...
I never made it down to the last sentence of this.
These studies may identify new therapeutic approaches for SMA. So I wanted to ask, so we should ask Daniel, how does this identify new therapeutic approaches?
I have to say, this is one area, and any medical students listening will tell you that the best way to get a person to fall asleep is to inform them that you're going to be discussing the complement system.
Exactly.
And but unfortunately, so I had a patient that we just discharged from the hospital yesterday who kept having these recurrent inflammatory issues, and our current working theory that we're trying to explore further is that we think it's an issue with the complement system. And we have these hereditary angioedemas, so people can have issues with complement that we see sort of as genetic rarities. And so there are ways to potentially to intervene. And here they're suggesting that maybe severe malaria is an issue with a overexuberant complement activation, a failure to protect the RBCs from destruction.
Right.
And so this potentially, if everyone can stay awake long enough to do the research, this might be a way to jump in and protect, as they point out here, these young children. Majority of these deaths are children under the age of 5. It's that window, the when you stop breastfeeding and stop getting the protection from the mother's antibodies before your pre-immunity starts to develop, you end up potentially with the severe malaria. So if there's some way to intervene, this hundreds of thousands of children potentially could benefit from such a therapy.
So why can't you use an anti-malarial drug to just...
so you can.
Of course.
Yeah. So this would potentially be complementary.
Got it.
Sometimes they're resistant to the.
Yeah, understood.
Yeah.
Okay. And because this might target the host, maybe you would not get resistance, right?
Well, what are the consequences of an overproduction of CD35? I mean, is that going to prevent immunity that's dependent upon the cascade effects of,
that's, whenever you turn off your
start
immune
tinkering
system.
with this stuff, and you're in trouble right away because there's a missing part.
If you made something, you'd have to test it in animals and make sure that there's no untoward effects, right?
I can think of a good animal model.
Well, that's the other thing. Indeed. Which one would you pick on this? Because you've got one that's high responder, or the other is a low responder.
Well, you want the rhesus because they're getting the anemia.
You got to try to protect the rhesus mechanics.
Yeah. But see, they only use 4 because they're expensive.
No kidding.
They can't use big numbers.
Yeah.
That's right.
And also they're cognitive advances.
I remember
there's ethical issues too.
Absolutely.
I was in a malaria lab when I was on my sabbatical in Australia, down in Melbourne. And I remember one of the researchers half jokingly said, we're working on a malaria vaccine, and the first thing we're going to do is try it in people. And then if it works, we'll try it in monkeys, because the monkeys are very expensive.
Well, in fact, I wouldn't use monkeys until you had a candidate that you
were
push forward. I would use a different animal. What other animal can you use? Nothing else?
A lot of this you can do in vitro now.
Yeah.
Because we've got an in vitro system for growing the parasites in red cells. So you can see if there's blocking antibodies and stuff like that.
I mean, for safety, I would say, let's say we have a CD35 interactor. Let's put it in just a variety of animals just to see if interfering is.
Yeah, could you just give it to a mouse and see if there's any, a rat, see if there's any.
That's right. And they can humanize these animals now, apparently. So
yeah.
I guess we've come a long way in the last 10 years of
we've come a long way, baby.
Immunobiology.
We have.
That's right.
And speaking of coming a long way, let's do another case.
Okay.
So we can get the new year started.
Indeed. Now, we were going to do a hero, but I was going to suggest Dr. Harold Brown, but I have a feeling I've already done him. If we can look him up in our archive, just to make sure that I haven't said anything.
Harold Brown?
Harold W. Brown.
Well, I just Googled Harold Brown TWiP and nothing came up.
Okay, fine. Then I'm free to do that.
So I think you did not do it.
That's fine. Well, we'll do it after he reads the case then.
Do you want to do that first? Or?
Okay, I can do it first.
Why don't you do that? Let's just keep our...
Let's just start by saying that Harold W. Brown remains on my list of parasite heroes at the top of that list. Okay, so he's there for several reasons from my perspective, but I have a feeling he's there on a lot of other people's as well. He was magnanimous to a fault almost, a very humble person, a very dedicated person to education as well as to a clinical diagnosis of parasitic infections. And he worked at Columbia University from 1948 until I believe it was 1983, when he retired. I think he retired before that, but actually he's no longer alive. I became a technician at Columbia in 1964. I'm sorry, 63. I'm blocking. No, I'm blocking.
Close enough, Dickson.
No, it was 62 actually. When I graduated from college, I got my first job, and that was here, and that was the summer of 1962, and I became a trainee in Dr. Harold Brown's laboratory, and he had a sort of a stable of trainees that he was training to diagnose parasitic infections. But he would also take trips around the world, sponsored by the China Medical Board, which was an outgrowth of the original hookworm control program in the United States, by the way, which if you want to go back far enough. So Harold Brown, born in Sheboygan, Michigan, educated at Vanderbilt University and Johns Hopkins, Vanderbilt for his MD, Johns Hopkins for his Doctor of Science degree, so he had a double degree. His first job was at University of North Carolina. He was offered a position at Columbia shortly thereafter, which he then accepted, moved to New York with his family, lived up in Dobbs Ferry, and was the parasitologist on staff here from 1948 until he retired in the 1990s, or 1980s rather. He trained many people, and because he was so modest and knowledgeable, And he loved humor, so he liked to include a lot of humor in his lecturing as well. People misjudged him, and they didn't take him serious enough in some instances. And behind his back, they used to call him Stoolie Brown because his last name was Brown, and of course that fit with the stool color, as we were just discussing. As a result,
how unpleasant and unprofessional. But
how unpleasant and unprofessional can you imagine? But everybody develops a moniker based on some of their characteristics. But the moment any of those people came back from a trip, especially to the tropics or subtropics, and they had an unexplained diarrheal disease, it was always Dr. Harold W. Brown. So he became a fan of this rumor that they were sort of making fun of him behind his back, because he knew damn well that when they got into trouble, they would turn to him for the answer. And he was persistent to a fault almost in finding out exactly what was wrong. And he was not at all the center of attention. He used to collaborate with lots of other people. In other words, he used to share that case history with lots of others in his milieu, and working next to him and seeing him behave was inspirational, I must say. It gave you the ability to be as humble as he, because you could never know as much as he does. And because of his experience, and he's a voracious reader, and he wrote a lot of papers. He did a lot of drug testing and that sort of thing, as a way of generating money for the laboratory. But he was also voted Teacher of the Year many, many times at Columbia by the students. They loved him because he loved them. And he wouldn't call them students. That was not his moniker for those people at all. He would call them his young colleagues. So when you tell somebody that the only difference between you and me is a couple of years of age, I've had a little more experience than you, but outside of that, we're the same. At that point, it cuts through all of this BS, as I would call it, of hierarchical highfalutin behavior. He was definitely not into that category at all. So he could teach that by example. And in doing so, he was a remarkable person. And I was his technician for a couple of years. And I used to help him teach by showing the slides. And in those days, we used lantern slides, these big glass slides.
Yeah.
And I remember one time one of them was upside down. And he didn't stop at all. He just says, and this is the way the parasite looks in Australia.
Yeah, it's great.
And that was like an instant, when you see that, and then afterwards he says that was not a problem at all. He used to help him set up the exams, and a lot of the exams that he used to give here were microscopic examination and diagnosis with the case histories. And so I cut my teeth in parasitology by being privileged to sit next to him and just watch him approach a subject, and he was amazing. He was absolutely amazing. So he's number one on my list of.
I guess you would say that you what you are is largely a product of his influence, right?
I think that's right. I would love to think that I have even a small amount of his humility and his ability to say, I don't know the answer to this, so I'm going to go ask somebody.
Yeah, you do have humility. Yes.
I think
you treat people equally.
Well,
yes.
I try to, of course, but one never knows. And neither did he, of course. He didn't have a clue, but he would come back with the most amazing stories. His favorite tea time behavior was a cup of hot tea, not sweetened, and 2 oatmeal cookies. And he would sit down after coming back from one of these trips around the world, and he would regale us with all of these wonderful stories about these things that Dr. Griffin brings to the table now. These are fabulous examples of human behavior and politics and the lack of proper sanitation as a major cause of disease that can be easily fixed if the country ever got behind that idea. But of course they don't in many cases. So you see all these things and you still deal with the problems. And that's the way he maintained his whole life that way. And I think of him often, and he produced the first parasitic disease book, and it was homemade, basically. Dr. Kathleen Hussey, who worked in his laboratory, and Dr. Roger Williams, both of those people contributed photographs and anecdotes and memorabilia to the textbook as it rose up and as soon as he retired, Dr. Michael Katz and I picked up the banner that he left behind, and that's the origin of that book. And that was inspired by his book. So I can say definitely that the contents of this book would not be possible without the beginnings of his own textbook in parasitic diseases.
So I had him once for a lecture.
Did you really?
At Mount Sinai, he used to come and give the parasitology lecture. I took microbiology with medical students.
Oh, good for you.
It was 1975.
Yeah, no, that's right. That's right.
And he came and gave a lecture.
Yeah.
I remember that.
Yep.
Yes. I don't remember any of it, but I know that he gave.
Yeah, no, that's right. So in the years that progressed after he retired, Dr. D'Alessandro, who was the chairman of our department, and I invented this sort of refresher course for physicians that wish they could learn more about parasitic diseases, et cetera. So we had this as a 2 or 3 day course on the weekend. And I had the pleasure of inviting Harold W. Brown to give several of the presentations. Cool. And he was absolutely appreciative of the fact that here's a technician, a student, and now a faculty member, the same person, who's now in a position to offer me the ability to address students still.
Wonderful.
So I loved him, and he loved everybody that he was associated with. He was a good man.
Unfortunately, he doesn't have a Wikipedia page. He should have one. Maybe
he doesn't,
maybe you can help me develop one.
I would love that. And I can tell you that not too many people, though, get their portraits painted by the official portraiture department at the Columbia. And he's got his
Where is his portrait?
It used to hang in Bard Hall because that's where the students lived. I don't know what happened to the portrait, but it's someplace. I know it's
let's find it.
I would love to.
We'll take a picture of it.
I have some.
That would be nice to put in the show notes.
It would be. Yeah.
I've got all these heroes hanging on my wall outside. A lot of them we've discussed. They appear in the book. All those pictures came out of a garbage can that he and I.
Who is the historian here that would know where his picture is?
Well, there is a portrait department that handles the official department.
All right.
Yeah, the portraits for the faculty.
I'm sorry, I interrupted you.
You
got some portraits out of a garbage dumpster with him?
These were photographic replicas. They were not actual photographs.
And who did you comb the garbage with?
Harold Brown and I, we both saw them. Who was throwing these out? It might have been the city health department. It might have been somebody like that.
Wonderful.
But
Thank you,
we rescued them.
Thank you very much. All right. We have to wrap up here.
Okay, yes. So a case. We have another case. And I have actually a backlog of so many exciting cases that...
maybe we'll do a whole show of them.
No, one at a time. This is a recent case from my visit November to Uganda. And we have, just to give people the context again, we're in eastern Uganda. We're up in the mountains. It's the rainy season. And a 6-year-old girl is brought in by her mother. And she initially was brought in on Monday by the mother. And the 6-year-old girl is reporting several days of feeling poorly, headache, fever, muscle aches, just feeling pretty crummy. And she was seen in the clinic on Monday. At that point, they listened to her lungs, they examined her. Things were relatively unremarkable. We looked through the notes, and she had negative malaria smear at that point. So now it's Wednesday. It's a couple days later, and she returns. And I see her this time, and she's starting to feel worse. Fevers are a bit higher. Headache is worse. I examine the young lady, and her lungs are clear. But her belly, she's now complaining of some belly pain, and she says it's particularly on the left side. She's having some pain. And when I examine her, she has a very large spleen, extending about twice what a normal spleen would be in size. And so we have a little mini lab there. So I'm going to send her off to the lab. And then based on that, we're going to move forward with diagnosis and treatment.
Indeed.
Okay.
Your 6-year-old girl who is living in similar conditions to the 2 boys we talked about last time?
So she is actually living in a slightly better condition. So she is very clean, very well dressed. Her mother comes in also very put together, well dressed. So within the economic sphere of this area, they seem to be a slightly better off family.
So what do you think their house looks like?
Most of the houses have dirt floors, concrete walls.
And they have no toilet, right?
The toilet tends to be a hole that's been dug in the back, and then you're basically going to go on top of it, and you're going to be defecating into the hole. This young girl's going to have the same kind of dietary habits, so a lot of carbohydrate, rice, potatoes, yams, cabbage, beans. No mosquito netting. There really aren't much in the way of mosquito netting in this area, and as mentioned, we're in the rainy season.
So is it still possible to have fecal contamination of water?
Certainly.
Just like the other kids.
Now, a lot of the people in this area go and get their water from the stream, and I think I mentioned my friend Godfrey, who said if they go early in the morning, they believe it's clean, but that's not true.
This family does the same thing.
Yeah,
gets their water from the stream. Okay, and no siblings, right?
No siblings. Which, again, is sort of unique in this area, right? Usually families would have multiple children.
The parents are not sick.
Mm-hmm. HIV negative? You don't know.
HIV negative, and that's a good question. In this area, about 15% of the population is HIV positive. So she is HIV negative.
What is the population density of this area?
It's pretty dense in this area. I mean, it's rural, so you're not, high rises or anything like that, but it's very, pretty densely.
Okay.
So what you have here is the spleen, the symptoms, and the environment.
Right.
Yeah.
Right.
And remember, she had a negative malaria smear on Monday.
Indeed.
Right. All right. There you have it.
And I will mention on Monday, they did tell her to come back in 2 days if she continued to have symptoms.
Mm-hmm.
Fortunately, she did.
And she did.
Okay. Very good. There you go. Start your engines.
Exactly.
Right.
And get those light bulbs turned on.
You use the book. Read it. Don't just look at the pictures.
Yes.
That's right.
That is TWiP 179. You can listen to it on any podcast player, on a phone or tablet. Please subscribe. Very easy to do that. It's free. You get every episode. We know how many people listen. That helps us to raise money. And if you'd like to help us financially, consider supporting us. Microbe.tv/contribute. You could use Patreon or PayPal. I also should say that the organization of which Daniel and Dickson are members, Parasites Without Borders, they would also like to have some donations. So you can go over to parasiteswithoutborders.com and check that out. Similar modalities as we do. They also have a Facebook page, facebook.com/parasiteswithoutborders. Sophia mentioned it. You can see pictures of Daniel on his travels, but not of Dickson, apparently.
No, that's not as interesting. I don't see patients when I travel.
Instagram, PWB_worldwide, and Twitter, PWB_global. So you can follow them on the social media. Of course, you can contribute as well if you're feeling particularly generous or not.
I mean, we're not asking for a lot, just an abundance of generosity from a few people or a lot of people with a little bit of money. It all adds up to the same.
Your support would be very useful. We could use it because we have expenses. So
think of how fast your book could get to you if it could be mailed by air.
Could get faster if Vincent would just mail them.
That's right.
And of course, questions, comments, your guesses, TWiP at microbe.tv. Dickson Despommier is at triconello.org, livingriver.org. Thank you, Dickson.
You're welcome, Vincent.
Daniel Griffin's at Columbia University Irving Medical Center, parasiteswithoutborders.com. Thank you, Daniel.
Pleasure as always.
Good to see you. I'm Vincent Racaniello. You can find me at virology.ws. I want to thank Ronald Jenkins for the music and ASM for their support. You've been listening to This Week in Parasitism. Thanks for joining us. We'll be back soon. Another TWiP is parasitic.